Good morning. We're ready to make a foldable today. So we're going to make a foldable on our transformation, and it's going to be our transformation flip chart. So what I've done is I've taken 2 sheets of paper and I've cut them in half. And so I'm going to go step by step through this foldable, and you are probably going to have to pause the video on and off. And I know there's no way that we're going to get everything into one video, so it will be multiple videos. So please feel free to stop and catch up at any time. Okay, so what I've done is I've taken 2, not 3, and I know you have 3 sheets. I've taken 2 sheets, cut them vertically in half, and then I'm just going to take them and fan them out and make tabs about, half an inch. Okay, so I've got these fanned out, and then I'm going to take the bottom and fold it up. And I know some of you are going to want to trim it and do all your nice and neat stuff. If you have a stapler, you'll want to take and put 2 staples at the top, and so that you'll have your little flip book ready to roll. And so you should have 1, 2, 3, 4, 5, 6, 7, 8 tabs. And once you've got that, we're ready to go. Okay, so I have mine ready. And so we're going to go ahead and get going with this. I've got everything color coded. So before you get going, you may want to go and stop and get color coded pens. I've used black, pink, green, orange, and blue. And so this first thing, we're just going to put a title page on it. So we have transformation flip chart, y equals a times f of b of x plus c, quantity plus d. And so we're going to look at what does A control, what does B control, what does C control, what does D control, and kind of tie up all of our transformations. So the first flip that we're going to do is our parent. And so if you're looking at this, don't look at anything else, just look at this flap. This is our parent that we're going to change around. You know how when you're in class, I have you a nice little parent on the board. So what I've got over here is our parent too. So I'll bring our parent back in to help us out with all the movements. And so you will have that too. So when you see the purple come in, that's just our parent. And so we've got a monstrous looking parent, another one. Okay, so we're going to flip to the next one. The next one is, what does A, when it's being multiplied by the y plus d? What does that charge? How does that change in our parent function? So we've got our parent. Now we've got, I've just got a graph done, ready to roll. Okay. So we have a vertical stretch where the absolute value of A is greater than 1. We have a vertical compression when the absolute value of A is less than 1. So all you're doing is talking about numbers greater than 1 and fractions. Greater than 0 but less than 1. Okay, and then if A is less than 0, and you may want to go ahead and write negative under that, because some of you still struggle with that. So when A is less than 0, we're talking when A is negative, we will see, so when we have the negative outside of everything, that just tells me we're going to reflect over the x-axis. Reflect back to, no pun intended there, reflect back to geometry, and you'll know that the y becomes negative when we reflect over the x-axis. So your rule was xy transforms into x negative y. Okay, so we're going to do this rule down here. So I have a rule down here, y equals 2 times f of x. So that just says y equals 2 times y. And so we're going to take our parent and we're going to multiply all the y's by 2. So we're going to end up with negative 2, 2. We're going to end up with negative 1, 0. We're going to end up with 0, negative 2. We're going to end up with positive 2, negative 2. And we're going to still end up with 3, 0. So since I chose to do 2, the absolute value of 2 is greater than 1, so we have a vertical stretch here. Okay, next one, B. Okay, the B is going to control our horizontal compression. And it's going to be a horizontal compression when the absolute value of B is greater than 1. It's going to be a horizontal stretch when the absolute value of B is less than 1. And I'm just going to write it down here. We're going to reflect over the y-axis. If B is less than 0. So go back and see where B is in our chart. So if B is being multiplied by X, then we are going to have the horizontal compression. Horizontal movement is controlled by your X coordinate. So you're moving left and right. So that should make sense for us. So on this example, we're going to do y is equal to f of 2x. And remember, the x's behave just the opposite of what we think they should. So instead of multiplying 2 times x, we really are going to be taking our x and dividing by 2. Every one of them. Okay, so here's our parent back. So we have negative 2, 1. So that's going to give me negative 1, 1. We're going to have negative 1, 0. The negative 1 will be divided in half. So we're going to have negative half 0. Then we have 0, negative 1. Then we have 2, negative 1. So we have negative 1. I'm sorry about that. 1, negative 1. And then we have 3, 0, and that will give me 1.5. Uh, 1.5, 0. And so we have our new one. So I'm going to stop right here, and we'll come back in just a minute for the next couple of these.